Hey, welcome to the second episode of my Introduction to Blender tutorial series. The first episode was merely an introduction, and at the very end, we installed Blender. When you do so, you'll see something like this. Don't worry too much about these, all of these are changeable. The one big important one is select with left. Especially if you're on Windows, this will feel the most natural. Okay, so you've got default Blender, but I'm going to change a couple of things to help with the tutorial series, so give me 1 second. And here's my layout. It's very similar. Most of the stuff I haven't changed, and the things that I have generally won't impact the tutorial series. If it does, I'll mention it. One thing that does impact it is this down here. So this essentially is just a little readout that shows you when I'm pushing buttons. That kind of thing. So if you're ever curious as to what I'm doing, you should see a readout down here. If you're curious what it is, it's an add-on called Screencast Keys. Let's talk about the UI, because this is where most people get intimidated. There's a lot of buttons and a lot of panels. The good news is you don't have to know everything here, or even most of it. Think about what it's like going into a wood shop when you want to make something. You don't stop at the doorway and say, oh wow, that's a lot of tools. Before I can even start, I'd better learn every single thing about every single one of them. What you should do instead is to take whatever your vision is for the thing you want to make, learn the tools that are involved in making it, and save the rest of it for later. That's kind of what we're going to do here. So let's start with our vision. What we've got here are a bunch of icons for Factorio. Specifically, this is the vector art made by Planetfall for his mod Brass Tacks. He initially made these in vector art programs, but that kind of disagrees with Factorio's style. So we're going to use these as concept art and recast it in a 3D style using Blender. For those of you unfamiliar with Factorio, I'm going to give a simple explanation of these just to sort of motivate making them. These right here are what are called plates. They are one of the basic units of making stuff in the game. And because they're so straightforward, they'll help us learn the basic tooling of Blender. Now, some tools in the woodshop are more important than others. And in Blender, the one thing that everything else kind of revolves around is the 3D viewport. It's very rare you're going to have a layout that doesn't include one. So let's talk really quickly about those layouts. If you look along the top, you've got a bunch of tabs here you can click between. Each of these is a pre-made workspace. As you can see, a lot of them have 3D viewports, but not all of them. If you ever find yourself in one of these and you're not quite sure how to get back, you can simply go back to layout. But if it ever goes away entirely, you can click on the plus, general, and you can click on layout and it'll make a brand new one. There is a system by which you can set them up. Mostly it revolves around clicking on the seams, which you can either drag around or right click to get a menu. You've also got a little dot here, which is like 1 pixel big with no contrast. When you mouse over it, you get this little icon, which means you can click and drag out a new pane, but I'll go over the details as we need them. The only other thing I'll mention is that you can change which pane is which by simply clicking on this button here. This menu shows you all the different things this pane can turn into, and every single one has it. I mention this mostly because many YouTubers will in fact change their layouts a bit, and this is how they're doing it. But for right now, let's stay focused on the 3D viewport. The first thing we want to cover is how to look around. By default, rolling the mouse wheel will zoom you in and out. You can also click the middle mouse wheel and dragging around will pan around something. And if you just want to move side to side and up and down, you can hold shift, middle click, and you can look around that way. What's important to note is that your center is going to change as you do that. So if I move over here, and then I try to pan around, I'm no longer moving around the square. Square. Yep, it's going to be one of those days. If you want to be centered on the cube, simply left click select. On the keypad, press the period key. And there you go. Usually you got to zoom back out, but you're now back to panning around it. One issue that you may have is that if you're used to other 3D software, you may be used to navigating in different ways. If that's you, you can either go into Edit Preferences, or you can just press Control, but either way you'll get here. And if you click on Navigation, you may find some options here can help you set up the environment to something you're more familiar with. Okay, so now the meat and potatoes of Blender. Fundamentally, Blender is a 3D editing program. You're going to be manipulating objects in 3D space. While it's true that Blender has a lot of keybinds, there's 3 that you're going to be using pretty much more than anything else. That is, if you want to move, scale, or rotate this object. To do any of these, you select the object, you press the key binding, so for example G for grab, which will allow me to move it. You can press S to scale it, or you can press R to rotate it. The problem is, by itself, that is not super useful. In order to understand why, let's undo this with Control Z. And let's try to make the plate. Consider what the plate is. It's basically a flat square. If I'm starting with a cube, then the best way to get there would be to simply flatten it. But if I just press S, it makes the whole thing smaller. It's not going to flatten it. Instead, I'm going to press S. You can see the outline turns white to let you know that you're editing it. And then I'm going to press Z. Z is for the Z axis. And what that means is that I'm only scaling along the Z axis. That's not perfect, but at least it gets us in the right direction. The use of the key binding Z is a clue to the other two key bindings, which are X and Y. Pressing X, Y, and Z when you're using either grab, rotate, or scale will lock it to that axis in some way. For example, pressing G and then Y means you can move it in the Y axis. Press Escape to cancel out. Pressing G and then X will move it in the X axis. Pressing G and then Z will move it in the Z axis. And it's the same with scale. Pressing S and then X will scale along the X. Pressing S and then Y will scale on the Y axis. You get the idea. Rotation works similarly. Normally, if I hit R for rotate, it spins around an axis, but that axis is what's going through your current camera. That may not be what you want. If I want to rotate around the Z axis, press R and then Z, you can see I'm rotating around the Z axis, as if there were a pin right through the middle of it. If I press R and then Y, it rotates around the Y axis. If I press R and then X, it rotates around the X axis. Some things to be aware of for the future. There's a bunch of really clever ways that we can rotate and move these things. We can change the spot around which it's rotating. Right now it's going through the center, but we can change what is meant by the center. But we're going to build up those ideas as we see them. Just know they exist, and we'll get to some of the more important ones throughout the tutorial. Okay, so let's make this look more like a plate. Let me zoom in. I'm going to scale in on the Z-axis a little bit. That looks about right. One thing I want to add in are some slightly beveled edges. Let me show you what I mean. This is what an iron plate looks like in the game if you zoom all the way in. The reason there's 4 of them is just so the game has smaller versions to render as the camera zooms out to increase performance. For right now, let's just focus on the big one. The thing I want to draw your attention to are the edges. Notice how there's some brighter pixels here capturing the edge. It's not obvious, but from the way we have it right now, this won't capture that. If we render this as is, it'll transition from this flat top plane to this side plane here, and there won't be anything in between here. What we would like to do is to capture some of that edge light, and we do that with what's called a bevel. You can do a bevel in a couple of ways. In fact, the fact that there's many ways to do certain things in Blender is going to be a recurring theme. For right now, we're going to use this opportunity to learn about what are called modifiers. You can see the modifiers in the Modifiers tab over here, which is in the Properties pane. If you click on the pane type here, you can see it's a Properties pane. All of these tabs contain some kind of information that you can use to modify the scene in some way. From this yellow Object tab on down, these are the properties of the object. And the one we're dealing with now are the modifiers. In order to add a modifier, we simply click on the button that says Add Modifier, and you get this menu here. Just a quick note, if you're looking at tutorials from before 4.0, you may notice that this pop-up looks a little different. Before, it used to be that these 4 submenus were just one giant flat list, but with 4.0, they've organized them a little better. What's really nice is if you know the name of the modifier, in our case bevel, you can just start typing, and it'll come up. If you hit enter, it applies it. What's interesting is that these changes are live. That is to say, they have not been permanently applied to the object. Yes, the geometry has changed, but those changes update based on how you alter the values here. So I could, for example, change the number of segments and smooth out those curves. I could even delete this entirely and go back to where we started. We're not going to do that right now, but I do want to drive that point home. This modifier can be changed or removed after you've made it. Looking at this, one problem jumps out at me almost immediately. This corner here is very rounded, whereas this corner here is nearly invisible. The reason is because we never applied the scale. This one gets a little abstract, so I'll try to show you in concrete terms. We've changed the scaling of this object when we pressed S and Z earlier. Blender is keeping track of those changes because we made those changes at the object level. If you want to see what those changes are, while your mouse is over the 3D viewport, press the N key, N for numbers, and you can see here the scale value of the object. The scale value is 1 and 1 for the X and Y, but the scale for Z is very different. What's happening is that this bevel is being applied, and then this scale is being applied. To understand this, I'm going to undo the scaling with Alt-S. Alt-S, Alt-G, and Alt-R undo the scale, movement, and rotation respectively. Now watch this edge as I shrink it back down to the size we just had. So I'm going to press S and Z, and you can see it's flattening out. Okay, so that's why it's happening, but how do we fix it so all the bevels are the same? We do that by applying the scale. That is to say, normally this is what the object looks like when all of its scale values are 1. If instead we wanted this to be what the object looks like when all of its scale values are 1, we would simply apply it. To do that, we're going to press Ctrl-A. This may look like a pie menu for you, but don't worry, it's basically the same options. And I'm going to go down to Scale and click it. Now, you'll notice that the Z value is 1 for the scale. As you can see, it's roughly even. As I mentioned earlier, this is a live modifier. we can change the value of the amount here, which will change the amount of bevel we apply. I'm going to click on amount, and I'm going to drag the mouse. By default, dragging this is really sensitive, meaning it's kind of hard to get this to be in the exact position I need to get the bevel I want. What you can do is click and hold Shift, and that'll bring down the sensitivity, which will help you get exactly the bevel you want. This works in everything you can click and drag on. That looks pretty good to me, so I'll just let go. Now, the other thing is I changed the segments all the way up to 8. I don't know that we really need that much geometry. I'm going to lower this down to 3. Since I've done that, you can now see there are some hard edges here. This is called faceting, like the faces of a gem being cut by a jeweler. We don't necessarily want that. What we can do instead is we can right-click, we can click Shade Smooth in the menu, and this will tell Blender to smoothen the transition here. Under the hood, this is doing it by smoothing the normals, but if you don't know what that is, don't worry. We'll talk more about it later. So I'm pretty happy with how this looks. If you want to experiment with modifiers on your own, you can click on this and take a look at all of what's in here. I wouldn't get too bogged down in the details, but if you see something that jumps out at you and it'll help you make what you want, go ahead and experiment with it. As you experiment, the way to think about it is that the object enters at the very top here. It goes through all of these modifiers. So I could, for example, put on another one. This is the displace modifier. Don't worry about what it's doing. Just understand that it's going in the order of object, then bevel, then displace, and what comes out of the bottom here is what ends up on the screen. Right, so let's get rid of that. And we're going to go to the next logical place, which is to give this a material, because we probably don't want this to just be a gray blob. In order to do that, we're going to go into what's called the Shading tab. It's going to take a second to load, and when it does, we get this. Now, there's a lot going on here, so I'm going to break this down. First off, we're going to do a little bit of simplification. I'm going to right-click on this seam. I'm going to go to Join Areas, this right area here, over this left one here, and then I'll do the same thing here. You don't have to do that, but I'm trying to simplify things for the tutorial, and right now we don't need those. So the next thing is, this is a little weird to look at. You can middle-click and go around, and you can see all the different stuff. But let's say you're over here, and you wanted to center it. There actually is a trick. In Blender, in most modes, if you hit A, it selects everything. Even though all of that is off screen right now, it's still selected. What I'm going to do is hit A, and then just the same keystroke we used earlier, keypad period, it will center on this the same way it's centered on the object in the 3D viewport. This is another good lesson about how Blender tries to unify as best as it can most of its key bindings. So A will select all, the keypad period will focus on whatever's highlighted, G will grab and move, R will rotate, although it looks very weird here in the node menu, and S will scale, even though that's also weird. Anyway, let's break down what these panels are and why this one, our 3D viewport, looks a little different. Because Blender is a 3D modeling program, at some point it's going to have to do what's called rendering. This essentially takes the 3D world and turns it into a picture, which can be turned into a series of pictures, turned into video, and fun fact, Blender also has a video editor. And it's oddly capable too. We're not going to be using that to make this Factorio mod, but you should probably know it exists. Anyways, the reason the 3D viewport looks different here is because this is for a different activity. The one we were using earlier is one that's very effective for modeling. It's as easy on computer resources as Blender is really capable of being without going to wireframe. And in fact, these modes up here sort of go from the least amount of resources needed to the most. The one we were just on is called Material Preview. And what it allows us to do is to see what the materials are for these objects, instead of just that gray nothingness. To see it in action, I can come down here to its shader, and I can change this color. And now we have a nice bubblegum plate. Or something. Anyhow, the way this is getting its color is from down here. This is going to help us understand the way this whole thing fits together. These are shaders. This right here is a shader node. This is the output. What does that mean? In short, this is a type of visual programming language. If you're curious, it's called Open Shader Language. The reason it's been picked is because it's incredibly flexible, but most importantly, we have a graphical representation of how data flows in here. Importantly, we generally want these colors to match. Green means it's an actual shader, which is something that can be rendered on the screen. Yellow is a color. Purple is a vector, which essentially says it has 3 numbers associated with it. As a good example with that, you can see the scale has 3 numbers, the rotation has 3 numbers, the location has 3 numbers. Those would all be vectors. We also have gray, which represents a single number. You can see we have these things here, which we can slide around like you'd expect. And we also have some data under here. We're not going to be using too much of this right now. The things we're concerned with is how we can make this into a brass plate. Let me assign this a yellow color. And now we're going to make this look more like metal. We're going to be doing that by editing these values down here. We're going to make it more metallic. And that cat is going to meow. Hello. And we're going to take down the roughness. And now we have a nice shiny plate of brass. Now let's go ahead and name this material. This allows me to use it on multiple objects. We'll do that by coming over to the Materials tab here. These are the material slots. By default, it'll get 1, but you can, if you wish, add more slots and add more materials here, and then apply them to various faces of your mesh and thus get different things. We're not going to bother with that right now, but we will in the future. We're just going to name this brass. The eagle-eyed amongst you may have noticed that the name also changed over here. You can change it here as well. And you can also change what slot you're editing. This drop down here is where all of your materials are kept, and you could, if you had more, simply select between them, and later we will. One quirk of Blender is that Blender tries to get rid of all of the data it does not need. One way it does that is by simply not saving things that are not used. So if for some reason I came in here and I made a new material by clicking on the new material icon here, now you'll notice if I click on the material list, brass has a little 0 next to it. That means there's no objects that use it. It's not going to delete it. Rather, when I save it, it's simply not going to keep it. Sometimes that's not the behavior I want, particularly if I'm going to make a library of these things. To solve this, we click on this shield icon. This is what's called fake user. Now when I click on the material list, now there's an F next to brass.001, which is the new material it created. That F means there is a fake user, meaning that when I save the file, whether or not this is applied to something does not matter. It's not going to be deleted. Essentially, it's being protected, which is why the icon for this is a shield. It's kind of got a weird name, fake user, and it is something that hung me up, which is why I wanted to make sure to explain it. Anyways, let's undo our way back to where we came from, and now we can move on to the next step. There's a few more things we need to do in order to get a rendered product out of this. The first thing we're going to do is we're going to set up the camera. So let's go back to Layout, and let me zoom out, and you'll notice we have this object here. This is a camera. If I press keypad 0, I can look through that camera. And now we can see what the rendered final product will look like. Well, sort of. Obviously, we're still looking at this with the solid viewport, which is the gray blobby thing. We can move this to material preview. Now we can see the brass of the plate, but even this isn't quite right. The reason is because we need to actually go to the rendered view. Now, if I click on this, it immediately looks pretty weird. The reason is because, well, we have different rendering engines. Essentially what's going on is Blender is trying to use physical properties to create worlds where you determine how these things fit together. That is, the shape of the geometry in the scene, the materials that are on it, the lighting that's in it, and it tries to put it together in a physically believable way. But there are different approaches to this. Right now, we're using the Eevee rendering engine. You can see that if you go over to your Properties tab and you go to Render. Right now, it's saying the rendering engine is Eevee. Eevee is a rendering engine that uses principles that largely come from video games. That's not a perfect description, but it's close enough for right now. What we would prefer is one that's more physically accurate. If we click on the dropdown, we can see cycles. This one is much more physically accurate. It's what's called a ray tracer. So let's click on it. And right now, it still looks kind of similar. And it's probably hard to hear, but my CPU fan just sprung to life. Let's go over here to Device, click on CPU, and make sure we go to GPU Compute. We also want to make sure that this is white. I don't know what GPU you have in your computer, but if you want to make sure it's working, you can go over to Edit, Preferences, or again, you can hit Control, Comma. We're going to go to System. I personally have CUDA selected. When you go here for the first time, you may have none selected. I don't know a ton about all of these. I personally use CUDA. I'm sure there's reasons to use the other ones. I just haven't gotten a chance to really go over them yet. But right now, I'm making sure that my NVIDIA GeForce RTX 360 is selected, and I'm actually going to uncheck my CPU. I found this actually helps. If I check this, it sounds like you'd be throwing more horsepower at it, but personally, I found that it slows my system down. Your mileage may vary, so experiment as you like. At any rate, right now, we have a more physically accurate look. However, it's still just kind of a dull, flat plane. The reason is because it's not being very well lit, and we haven't really set up the camera so that it looks like what we want. So let's do that. It turns out that the camera is just like every other object in the scene. If you click on it, you can press G and move it around. You can rotate it. What we would really like to do is to precisely control its position and its angle. To do this, we can do one of two things. One, we can get out of the camera view by simply panning or moving somehow. And now we can see the whole scene again. And from here, we can simply hit G, hit Y, and try to reckon where it should go. This gets a bit tedious, and honestly, while helpful, it's not necessarily my go-to move for this kind of operation. Instead, I'm going to come over here to its transforms. Now, in order to get this menu, remember, you'll need to press the N key. And you'll also notice I have some extra tabs here that you don't. These are just some of my personal add-ons. Don't worry about them. The thing I want you to focus on is that you can set the location to 0. So I can either click on this thing and type 0, and click on this thing and type 0, and click on this thing and type 0. Or, let me undo those, show you a little trick. You can actually click and drag, and now I press 0, and I do it for all 3. Then I can come over here and change the rotation. And now I have this thing placed somewhere precisely so I can move it in an accurate way. So what I would like to do is to move the camera to a position where it's over top of this thing, but angled downward. Let me show you a couple of tricks to do that too. The first thing I'll do is I'll press R, and then I'll press X so it's rotating around X. And now if you see, I can move the mouse here and it'll rotate, but I want to get to a very precise angle. What I can do is while I'm in this mode, simply type the number 45, and you'll notice over here, the number showed up in the X. It's actually hard for me to point with it with the mouse pointer because this thing is off on the side here. But if I hit enter, and there you go. If I zoom in, you can see it's at a precise angle here. When making Factorio icons, it's often a good idea to use a 45-degree angle here so that the items look like they're laying on belts properly. As you can tell, we're looking at this a little bit slanted. Let's set our current viewport to look at this from the side with precision. On your keypad, you can press 1, 3, and 7 to look at it from different angles. I'm going to look at it through 3, and now we can see this from the side precisely. Something to note is that the viewport camera, the one we're looking through right now, is set to orthographic instead of perspective. Fundamentally, this just means there's no vanishing point, so all of these grid lines here are parallel. If I were to change the camera to something like this, you'll notice they sort of come together somewhere in the distance. This is what's called perspective, and this is how we view the world normally with our eyes. A thing to note, if you forget the key bindings, you can also click on one of the dots up here, and that will take you to one of these views. You can also use this to spin your view. Personally, I don't recommend that because having to go from clicking here in the screen to clicking on this thing up here kind of takes you out of flow. And personally, I prefer not to do anything that takes me out of flow. All right, so let's put the camera in place. There's 2 ways we can do it. One, I can go to the side view by pressing 3, selecting the camera, zooming out a bit, and then pressing G to grab, and moving it over here somewhere. You'll notice that I can't quite get it on this little grid point here. I'm trying to line it up here. This is fairly hard. I can, of course, come up here and do a little bit of touching up. I can see this is close to -4 and this is close to 4. So I could go -4, +4, and that'll work fine. The other way of doing this, too, would be from this perspective here. Simply press G and move it along the Y. Press G, move it along the Z, and then clean up the values here just as before. But here's a little trick. Let me undo that. I can actually press G, and instead of pressing Y and then Z, I could press Shift X. Now you'll notice that the Z and Y axis highlight. That's because I am now moving in the ZY plane. The reason is one of the points of ethos that the Blender Foundation used when they were making their keystrokes, and that is that Shift plus a keystroke is kind of like the complement of the original keystroke. In this case, pressing X locks it to the X-axis, and Shift X locks it to every other axis. Similarly, if I press G and Shift Z, I can move it along the XY plane, or if I press G and then Shift Y, I can move it along the XZ plane. Honestly, you can use whichever one of these works best for you. So let's look through the camera. That's fine. That's not really what we want. I can immediately see a couple of problems. 1, we're in perspective mode. 2, the lighting is bad. And 3, usually on belts, these things are turned a little bit, just like this here. It gives it a bit of character. So let's fix these problems in order. First, let's fix the camera. I'm going to select it, and then I'm going to go to its properties over here. You'll notice these have changed. I have a different thing selected. If I select an object, that camera icon goes away. If I select a camera, the camera icon appears. So this is context sensitive, just something to note. So if I click on this, I can come over to type and select orthographic. The next thing to note is that the aspect ratio is off. That is, how wide compared to how tall this is. We want it to be a square ratio. In order to do that, we'll go over here to the output properties. The resolution for the output is right here. For icons in Factorio, we'll set this to 64 by 64. And you'll notice that we're zoomed all the way out. To fix this, we're going to go back to our camera settings, and now we're going to change the orthographic scale. Something like that should be fine. There's no hard and fast rule for what the orthographic scale will be. My suggestion, if you're going to be using the same file to make all of your icons, pick a value and leave it like that. The options for the camera settings tend to be distributed across render and output and the camera that you've got selected. The reason for this is due to the fact that they wanted to decouple things in certain ways. I wouldn't worry too much about the details. If it's something that would be on the physical camera itself, you'd probably find the settings here. The output talks about resolution and frame rate, and the render settings then get into the details of how the renderer actually works. Okay, so let's make this look like an icon. I'm going to select the plate, hit R, Z to rotate on the Z axis, and I'm just going to turn it like that. Because there's no external thing saying how big or small this thing must be, I'm going to scale it up a bit, so I'll hit S, and there we go. Now, let's try to fix the lighting. I'm going to come over to the outliner here, and I'm going to select the light. A quick little blurb about this. This is one organizational structure for all the stuff in the scene. We'll be using this pretty extensively later on. But for right now, just understand that if I want to select something, I can click on this as well. So I can get the camera, or the cube, which is no longer a cube, or the light. So what I'm going to do once I've gotten the light, I'm going to zoom out, and I'm going to bring it in, and try to figure out where it would make this thing look the best. The problem I'm having right now is that I'm having a bit of trouble understanding where this thing is. I'm not sure if this is going to come through on camera, but if I zoom in, you can see there's this little dotted line here that ends where it's intersecting the XY plane. I'm going to bring it down. I'm going to move it over, this time moving in the XY plane, and then I'm going to bring it back up. I'll move it over again. Now I have the spot of light roughly where I would want it, but it's very, very bright. Let me try to fix that. In order to do so, I'll come over here. I'll click on its data properties, which in this case is not a camera, but rather a light bulb. I'm going to change this from a 1000-watt light bulb to, I don't know, let's try a 60-watt light bulb. And that's looking better already. Though there are many refinements we could make, and we will cycle back and touch this one again in later tutorials, the only one I want to touch on right now is to try to capture some of that edge lighting, which is what motivated us to put the bevel in the first place. To do this, I'm going to create another kind of light. This is a point light that we've got here, but I want one that will cast light across this whole edge. Let me show you what I mean. I'm going to press Shift-A, I'm going to go to Mesh, and I'm going to create a plane. I'm going to rotate this in the X-axis by 90 degrees, so I'll hit R, X, 90. We'll be doing that sort of thing a whole lot. I'm then going to rotate this on the Z-axis, so I'll hit R, Z, and I'm going to try to line it up at the edge like so. Now let me move this by pressing G, Shift-Z, and I'm going to move it back here. That way it's out of the frame, but we will still get some light from this. But hang on a second, what light? This isn't really emitting any. You can kind of see its reflection here, but that's not really what we need. What we're going to do is we're going to use an emissive material here. So I'm going to go to its material properties. I'll make a new material by clicking New. And here you can see its shader properties. Earlier, we had to go to the shading tab, and here we saw a node representation that we'll use in the future to make some really detailed shader networks. But as it turns out, when it's simple like this, we can stay in the Layout tab and simply work in the Material tab of the Properties pane. Now, technically speaking, these will represent the same data. However, depending on what you're doing, one will be more convenient than the other. Oftentimes, when my material is simply a principled BSDF, I do like to work here because making edits here means I don't have to get out of flow. That's going to be a theme you'll hear a lot during this tutorial. At any rate, let me go down here to the last one called Emission. I'm going to fan it open, and as you can see, it has a color and a strength. This means it's trying to emit white light. However, it's doing so with a strength of 0. Let's change that. So I'm going to click and drag. And now you see we get some edge lighting here. In the future, we're going to add a lot of detail, but for right now, we're going to call this good enough. It's in the development cycle, which means we're going to touch back on this in the future, but we'll do so when we have a better understanding of how these things fit together. So it's time to render. To make sure this comes out right, we'll go to the Render tab. We'll go down to Film. I'm going to click on Transparent, and you'll notice we now have a checkerboard. This means that when we render, these pixels will be transparent. If we didn't, this would look like gray pixels, and we would have a very strange looking icon. But with all of that in place, we are now ready to actually make a render of this. I'm just going to press F12, and there you have it, an icon. It's very small, so let me make this a bit bigger. Now, it has not actually saved it. What it's done is it's rendered it, which means it's in memory, but now we need to dedicate it to the hard drive. Quick note, this is probably a good time to save the file. Simply go to File, you'll click on Save As and direct it to where you need to go. I've already got it set up on my hard drive, so I can just click Save. Now if I head back to this thing, I'm simply going to go to Image, Save As. As you can see, it's not my first take. I can say I've already saved it. Just direct it wherever you want and type in the file name you want. I would suggest using RGBA, so that way you get the transparent pixels baked into the file. If you use just RGB, it won't have transparent pixels and you'll just have flat gray pixels there. And then we'll click Save as Image. And that's it. Congratulations, you've made your first icon. Let's do a quick recap of the key bindings. We've learned how to use the middle mouse button to rotate around an object. We've learned how to roll the middle mouse to zoom in and out, how to use shift and middle mouse to pan around. We learned how to use the keypad period in order to focus on an object. We learned how to use G to move things around, R to rotate them, S to scale them. We've learned how Alt-G, S, and R will reset them. We've learned how to lock things to an axis. So if we press G and then X, or Y, or Z, or Shift X, or Shift Y, or Shift Z, we've learned how to use A to select everything. And we've learned a ton about the different panels in Blender. We are going to be spending a lot of time with this stuff in the future. So if this is something you would like to see more of, click like and subscribe. If you want to go sign up on my Patreon, please feel free. But until next time, take care of yourselves, be good to each other, and I will see you in the next one.